You don't have to live in Alaska or the Arctic to see northern lights. I've been chasing and observing this mesmerizing phenomena for over 20 years now. I've seen or documented northern lights several dozen times, and believe it or not, to this day, I've never been further north than the Keweenaw in Michigan. This is Michael from Science Out There. Thanks for tuning in to part 1 of my Aurora forecasting series. There's a good chance you may have seen one of my videos, which I took from well south of Grand Rapids, Michigan, about 8 years ago.
Look at this time lapse from Michigan. You guys could see this as far south as Alabama, even into Georgia.
Jackie, how often does this happen?
I've
never seen anything like this.
Oh, it happens every now and then. You know, it's more prominent really near the equinoxes, and this time of the year you can see it a little bit easier because often you'll have clear skies and a very nice dark sky to be able to see it. This was kind of on the weak side in terms of solar storms. On a scale of 1 to 5, it was only a 2, so people don't need to worry about things like, you know, losing their GPSs or their cell phone reception. But what a great display.
Over the course of this series, I'm going to show you how you can see the aurora from your own backyard, teach when to look and what to watch out for, and finally, at the end of this series, how to observe and photograph northern lights. Armed with this information, I can help you see the northern lights from where you live or from where you might be going on vacation. In the first part of this series, I'm going to orient you with some lore, terminology, solar cycles, the magnetosphere, geomagnetic latitude, and the KP index. Armed with all this, we can later dig into the hard stuff. My grandfather told my father a story once about how he saw a deep, bright red aurora overhead in the skies over Michigan when he was young. I think the story goes that he was out fishing at night when the sky and the water erupted in shades of red. World War II began soon after. He thought of the event as being a bit of an omen, and who could blame him? World War II began right in the middle of a solar maximum, or a period of time when sunspots are large and solar flares are strong and frequent. The result of this activity is more frequent northern and southern lights. Solar maximum occurs every 11 to 12 years, with solar minimum years in between. Maximum can also refer to the couple years on either side of a peak. Solar maximum is defined as having the highest sunspot quantity visible from Earth for a given day. And if you overthink it too much, you can find all kinds of big events that have occurred during these solar maximums and make them loosely fit that pattern. Most often cited are the coincidence of major conflicts. Currently, there is no scientific link between human behavior and solar cycles. It's likely just another example of matching astronomical patterns to things that are already cyclical by their very nature. Aurora is a Latin word that means dawn. Aurora is usually paired up with their location, Aurora Borealis and Aurora Australis. All of these are Latin and translate literally to North Dawn and South Dawn, or better known as the Northern Lights and Southern Lights. Anytime northern lights appear, so do southern lights. But while their strength at any given time might be the same, they're not perfectly mirrored and may behave a bit differently during a given event. Aurora are a type of space weather, or more accurately, the result of space weather. Just like regular weather, it can be predicted perfectly and with pinpoint accuracy every time. Yeah, no, forecasting is hard. But we can, however, predict with some amount of skill how and where aurora will be visible within an hour or two, what the immediate chances over the next few days are, and we can even predict what the general prospects will be for aurora in the coming months or decades, much in the same way we know winter will be cold and summer will be hot. Just like weather, there are changes over time, seasons, variations, some of which we have a really good handle on, and others we are just beginning to figure out. I'll just go ahead and coin this long-range concept to be something called space weather climatology, so you may hear me say it again later in the series. Aurora are caused by charged particles leaving the sun and smashing into Earth's magnetosphere. This is always happening 24/7, but the strength, density, magnetic polarity, and speed of the solar wind can vary widely from day to day, or even change very suddenly. All of these parameters matter, and that's where short and medium range prediction comes in. Sources for stronger solar wind include holes in the sun's corona. The corona will normally slow down the solar wind leaving the surface of the sun, but gaps can allow much faster speeds. Another possibility are large chunks of solar matter leaving the sun in bursts, called coronal mass ejections, or CMEs. CMEs can be produced by collapsing filaments or prominences, but the most powerful and even most dangerous forms of CMEs come from sunspots. Bigger and more complex sunspots can produce bright and long-lasting flares that sometimes also produce CMEs. Holes in the sun's corona and the appearance of sunspots happen in monthly and even decade-long cycles. Because the solar wind and CMEs have days-long lead times before interacting with Earth, we can get a sense of what the coming days and even weeks will be like as far as the strength of northern lights. Northern and southern lights appear, for the most part, in an elliptical shape around the Arctic and Antarctic. But instead of this oval being centered over the Earth's poles, rather it is centered over the geomagnetic north and south poles, both of which are offset a bit from the polar axis. That's extremely important, and I'll come back to that. The long end of this oval points away from the sun. Now that too is important because that means northern lights will appear furthest from the poles during a given location's local midnight. Now if you live somewhere that has daylight savings time, you need to remember that local midnight for you might actually be 1 a.m. The reason aurora appear near the poles is due to the nature of Earth's magnetosphere, a large elongated dome of electromagnetism generated by Earth's spinning liquid metal core. Just like a magnet, the magnetosphere has a north and a south. These don't line up with Earth's polar axis, but instead intersect with Earth's surface at about 10 degrees offset from Earth's poles. In the northern hemisphere, this is in the direction of North America, while in the southern hemisphere, this is closer to New Zealand and Australia. Now why that's super important is that the auroral oval I mentioned earlier is also offset from Earth's poles by 10 degrees. This means that in general, northern lights slightly favor North America, or in the southern hemisphere, Australia and New Zealand. Because some locations are so far north, aurora are visible almost any night of the year close to the poles, such as Iceland, Alaska, Siberia, and Scandinavia. There's just one minor problem with viewing the aurora from Arctic locations. For a good chunk of the spring and summer, there really is no night. The sun doesn't set north of the Arctic Circle, or the light of dusk and dawn are too bright to see aurora. Watching northern lights up in the Arctic means that it is either extremely cold, or it isn't dark enough, or sometimes both. The exception is northern autumn, when nights get longer, and the weather hasn't turned as frigid yet. Fortunately though, there's a sweet spot. Because the auroral oval is offset toward North America, a large section of southern Canada can experience northern lights any night of the year, even in midsummer. Just bring plenty of bug spray. The auroral oval doesn't really care whether it is winter or summer. So keep in mind that the entire polar region in winter can see northern lights just fine, even sometimes all day or night, whether that's southern Canada or Alaska. Just bring your parka and mucklucks. Northern lights aren't static. Sometimes they are weak, green, snake-like twirls across the sky. And when they strengthen, turn into curtains. And at their strongest, creep far south from the normal oval, extend many hundreds of kilometers in height, and turn an ultra-bright red. Now let's talk about your geomagnetic latitude. In the news right now is the acceleration of the magnetic poles across the Arctic from North America toward Siberia. However, this isn't exactly the same as geomagnetic north. Magnetic north is where your compass will point, and geomagnetic is a true magnetic axis of Earth if it were just a simple bar magnet. The two don't perfectly match. Geomagnetic north and south is what we are interested in. In the northern hemisphere, this lies right over Ellesmere Island in Nunavut, Canada, tilted slightly under 10 degrees away, or about 1,000 kilometers from the actual North Pole, and on the 72 degrees west longitude line. If you happen to be in the eastern United States or Canada, for example, your geomagnetic latitude is 10 degrees higher than your geographic latitude. 45 degrees north latitude becomes 55 degrees north geomagnetic latitude in North America. In Eurasia, the opposite is true. The geomagnetic latitudes can be 10 degrees further south, placing any given location much farther away from the auroral oval. Thanks to the quirks of geomagnetic north being closer to the United States and Canada than it is to the rest of the world, this means that warmer climates, even during summer's shortened nights, can see the northern lights fairly often. The KP index is a 3-hour-long measure of geomagnetic fluctuations on a scale from 0 to 9, taken from various places on Earth, and applied as a weighted average to the entire planet. K is the German word Kennziffer, or reference number, and P is planet-wide. The KP index tells us how disturbed Earth's magnetic field was from rest, and can tell us roughly how powerful the northern lights might have been during that 3-hour window and who might have been able to see them. The KP index is not a forecast, but rather a look back at the last 3 hours. I'll be taking a deep dive into the KP numbers in the next episode. So what does that all mean and how do we put this together? First, when the aurora strengthens, it extends further south, and at local midnight across the United States and southern Canada, aurora can become quite easy to view. Second, not only does strengthening mean it extends further south, the increase in height that comes with it further allows places in the central United States or even further south to view aurora on the northern horizon. All you need to know is how to forecast the aurora, how to look for them, and when to look for your given location. Thanks for watching, and if you enjoyed that video, hit that like button. And to make sure you don't miss that next episode in my aurora forecasting series, Be sure to hit subscribe and ring that bell. And as always, get outside and learn something new.